All right, welcome to Monday the 6th. Today we're talking about lesson 15. Tomorrow we are doing not necessarily a Schoology segments. We're actually going to do lessons 11 through 15, okay? So that'll be on a quiz in Schoology tomorrow. And then for the rest of the week we have 16 we're finishing up, and then we'll finish up with angles. So we'll have a review of angles. And I know we did a review of segments in your packet. That may change, I'll let you guys know. Because we mainly focused on angles during this module. And then the week after that is normally going to be our spring break, which New York State is kind of tailoring back. But we're going to just do a get caught up week here. So focus on making sure you get all your lessons done, all your quizzes done. If you need to retake something, please do that. And we'll also have some days of review in here. We'll have a couple topics for review we're going to do. So that'll be more information coming out on that as we get closer to it. But for now, lesson 15. All right, so just a review of what we talked about last time, which was if we have an angle formed inside the circle, and I'm just going to fix this real quick. All right, that if it's formed inside the circle with two chords here, okay, these chords are forming two arcs, and the intercepted arcs that measure the angle is equal to the sum. So actually the average of those two arcs, the sum then divided by 2. So once again, my angle here is formed by two arcs. There's my angle. Okay, so I add the arcs and then divide by 2. We're not going to go into the conjecture stuff. We already know what's going on with these guns, okay? So interior case, once again, if it lies in the interior of the circle, okay, it's half the sum of the angles, the average. So we're just going to do add and divide by 2. So find the angle, follow the sides of the angle up, okay, to find your intercepted arcs, and then add and divide by 2. All right. Now, same thing here. Here's your angle. There's your arcs. Add and divide by 2. Now, what we're going to focus on today is angles that are formed outside the circle, okay? So we just talked about angles inside the circle. Now we're going to talk about outside the circle. So the key thing to remember here is the saying we're going to use is that outside is different, and difference in math means subtract, okay? So whether we form it with two tangent lines, okay, two tangent lines, like our hat rule that we talked about before, okay, a secant line and a tangent line, sorry, two secant lines, I should say, so like two secant lines that cut through the circle twice, or a tangent line and a secant line, tangent and then the secant. Either way we do it, we're going to end up cutting two different arcs with that angle. So you can see the first time the two rays cut through the circle, I'm making a arc that's closer to the angle. So AC looks like EG or KL. We're getting this first arc, and then the angle continues, the rays continue through, and it creates a second arc. Okay, here it's AD, here it's IH, here it's KML. Okay, and so to figure out the measure of the angle, remember outside is different, we're going to do half the difference. Okay, so I'm going to take the bigger arc minus the smaller arc, and then I'm going to divide it by 2. So AD minus AC, big minus small, right? All right, here it's HI and EG, half of that, so HI, EG. And then on this one, the bigger arc is KML minus the minor arc KL, and divide by 2. So bigger minus smaller divided by 2. That's our formula, okay? So no matter what the diagram is, if it's outside different, we're going to subtract, okay? So going back in it, we can take a look at the first one. Our angle is outside, and you can see I'm creating these two arcs. So follow the sides of the angle up to see the two arcs. So B is the smaller, C is the bigger. So it's half of C minus B. Outside is different. Okay, here's angle C. Here's my two arcs. Okay, so it's 1/2 bigger minus smaller. Okay, so whether you want to write it 1/2, right, big arc minus small arc, all right, like this, or you want to do the big arc minus the small arc divided by 2. It's totally up to you how you want to write it, okay? Here I'm kind of writing as a fraction. On the note sheet, it's 1/2. It's interchangeable, okay? So it's up to you. Okay, we're gonna get right into some questions here. So let's take a look at exercises 1 and 2. So on exercise 1, I have x is my angle. Remember, x is outside, so the rule outside is different. So I'm just going to subtract the arcs. So remember our formula. 1/2 the big arc minus the small arc, and I have to put parentheses around this because I'm doing half the difference. Okay, so it's 1/2 of the big arc, which is 82, minus the small arc here, which is 26. So 1/2 of 82 minus 26, we're going to go ahead and borrow. It's 6, it's 56, and so this is 28 degrees. Now, obviously, you don't have to necessarily show all this work. As long as I can see your formula and your answer, I'm good. Okay, so if it looks something like 82 minus 26 divided by 2 was equal to 56, that's fine. That's enough work to justify what's going on here. All right, and of course we'd want to put x equals in front of that because that's the measure of our angle. So in the second one, okay, I have my two tangent lines, which are intersecting the circle, and they're creating the big arc, which is 252, and then we have this smaller arc that's formed between D and E. Now these two arcs make up the whole circle, so this arc, okay, is going to be 252, but I'm going to take that away from 360. So 360 minus 252 should be 108. All right, and then we're going to do x is equal to not 360, bigger minus smaller, guys. So 252 minus 108, and then divided by 2. All right, and so we can go ahead and subtract. So we'll borrow. That should be 144 divided by 2, and so x is equal to 72 degrees. All right, always terrible at the degree measure on this. Okay, so that's 1 and 2. Number 3 isn't really in the same type of question. What's happening is that these two lines are actually creating an isosceles triangle. So what I really want to do is connect to form an isosceles triangle and then figure out the base angle there. And so you can see that this angle is actually inscribed to this entire arc. All right, so I'm going to use x, really. I want to figure out the measures to these two base angles and then figure out x from there. So this question is kind of weird, but we'll go through it. So this arc is 360 minus 215, which is 145. And so this angle y is inscribed to that arc. So I'm just going to divide that by 2. Okay, so 145 over 2 is 72.5, and that's the measures of these two angles. Okay, 72.5 and 72.5. So angle x is just in that triangle. So that's 180 minus 145. That's 72.5 put together, right? And this is equal to 35 degrees. And so that's the measure of angle x right there. All right, number 4, another weird, tough question here. And the key thing is that we have these parallel lines. We have this z that's sort of going on here. So, all right, angle z is actually the same as this angle, okay? And this angle is kind of neat. It's formed by that tangent chord, right? So that angle is half of this arc. And this angle is also half of that arc, right? That's inscribed to that angle. So if I can figure out what this arc is, I can get x and y, z and y, and that'll help me get x. And so the strategy here is I have no idea what the measures of the arcs are, okay? So I'm going to let this purple arc be x, okay? I'm going to call that x. Now actually, I shouldn't use x because I already have an x and where angle D is here, okay? I already have an x. So let's call it something else. Let's call it A. So that's the measure of arc A, and the entire other side of this is going to be the other arc. and this is going to be B, okay? We'll call that B, lowercase b, not capital B. So if I know the measure of A, then B would just be, well, it forms the whole circle. So that's 360 minus whatever that smaller arc is, A. And so now we can figure this out because we have this outside angle, and remember, outside is different. So 56, okay, is equal to, all right, the measure of the bigger arc, which is 360 minus A, minus the smaller arc, and then divided by 2. So this I can cross multiply right away and combine like terms. So this is 112, okay, is equal to 360 minus 2A. And then what I'm going to do is get the A's by itself. So I'm going to move the 360 over. Now this will give me a negative amount, but this is equal to negative 2A. So eventually I'll end up with a positive A here. So when I subtract this out, this is 248. And then I divide a negative because the 360 is bigger. But when I divide by negative 2, I'll get a positive answer. And so this is 124 degrees for A. I'm just going to double check that on the calculator. All right, so 360 minus there. Yep, 124. Okay, and that is the measure of this arc. So this is 124 degrees. And so now I should be able to figure out the rest of the stuff. I just realized that was 66, not 56. So I'm going to go back and change it to 66 here. So 66, right, which is going to make this 132. Okay. You're probably like, he's doing it wrong. All right, so 360 minus 132 is 228. Okay, 228. So we can go ahead and change this. And this is going to change. So negative 228, which is positive 114. 114. Okay. So let's go back and fix this. So this is 114. Okay, so now we can figure out the measure of all this stuff. So we know that this angle, where y is, right, is inscribed to that arc. So y is equal to 1/2 of 114, which is equal to 57 degrees. Okay, and remember what we said before, this angle, right, is formed by that tangent chord. So this is also 1/2 of 114, which is 57. And then our z gets us all the alternate interior angles here. Okay, the z is going to make sure that this angle is also 57 degrees. Okay. And so now I can get x because I add those two together. So angle x is actually going to equal 180 minus 114, which is going to be 66 degrees. So I got 66, 57, and 57 for the measures of those three angles. Okay. On the next page is just a wrap-up of what we talked about for the angles here in the circle formed by the tangents and secant lines. So the first one is these two chords or secant lines. You want to talk about the angle that's formed is on the circle like this is an inscribed angle, and so that measure is just 1/2 of the arc. So I'm not going to go through the two shapes overlapped. It's an inscribed angle. That's the important thing here, okay? This is just inscribed. So B is equal to 2A, so the arc is equal to 2 times the angle, and the angle is equal to 1/2 the arc. Pause if you need to copy down. I'm going to keep going here. The second one is formed by the secant or chord in a tangent line. And the reason we can say it's a chord instead of a secant line is if I got rid of this part of the line, right, still going to be the same rule. So here's a chord in a tangent line, so it still works. All right, but the rule and everything is the same. This angle still on the circle formed by a tangent and a chord or a secant line is equal to 1/2 that angle. or half the arc. So the angle is equal to half the arc. So the angle equals half the arc, and the arc is equal to 2 times the angle. The third one is formed by two secant lines. It's an angle, though, that's inside the circle. Okay, remember inside is average. So A is going to equal the arc B plus arc C, and then divided by 2. If you want to put down 1/2 B plus C, you're also more than welcome to. It's totally up to you. We'll do A equals here too. All right, and then on the next one, angle outside the circle. Okay, so this angle is outside the circle. I'm going to put angle on the top. Okay, remember the rule is that outside is different, and different means subtract. So A is equal to half the difference. So it's bigger arc minus smaller arc divided by 2. So C minus B over 2. This is the same thing. Whether it's two tangent lines, right? This angle is outside the circle. Angle is outside the circle. Outside is different. Different means subtract. So A is equal to bigger minus smaller divided by 2. That's it. That's all we're looking to do here. So there's your theorems. Okay. The secant angle, the interior case, so if the angle's inside the circle, right? It's equal to half the sum. It's equal to the average. And if it's outside the circle, it's equal to half the difference. So outside is different. Different means subtract. Okay. Remember, secant line intersects the circle in exactly 2 points. So let's take a look at number 1. Okay, my job is to find x. So I'm automatically noticing there's an angle involved. Where's the angle located? It's outside. So remember, outside is different, and different means subtract. Okay, so the angle is always equal to, okay, the big arc minus the small arc and divided by 2. Big arc minus small arc divided by 2, okay? So 28 equals the big arc, which is 3x minus 4. Now this is an expression, so I need parentheses around this. Minus the small arc, which is x plus 4, and then divided by 2. I always like it as a fraction, just personal preference. So if you like putting the 1/2 in front, go for it. Okay, the next step is going to be, you got to remember, because there's parentheses, that I have to distribute this -1 here. Okay, which you're supposed to be happy with the rainbow there. We're going to then cross multiply. So we get 56 is equal to, now it's 3x minus x. Okay, so this is really 3x minus 4 minus x minus 4. So now I get 56 equals 2x minus 8. I'm going to move that 8 over first by adding it. All right. So I'm going to get 64 is equal to 2x and divide by 2 to get 32. Okay. Now I'm showing every step along the way here. So if you short it down a little bit, that's okay. All right. So we want to find the measure of angle DFE. So let's find these angles first. So DFE is this angle right here. Okay. We want to find that one. And we want to find angle DGB, which is this angle right here. Okay. Now they're giving me some other information in this question. Number 1, I have this angle outside the circle. So that angle outside the circle, right? And I'm going to redraw that because I don't like these real thick lines that kind of cover up stuff. Angle outside the circle, or outside is different. And so you can see this is creating 2 arcs here and here. And the angle inside the circle is actually an inscribed angle, okay? And so the inscribed angle is creating that same first arc BF. So I can use this 25-degree angle to tell me that BF is equal to 50 degrees. Remember, inscribed is half of the arc, okay? And then I need to try to figure out this angle right here, all right? Now, I can see that 2 things. Number 1, this angle is what we're trying to find. This angle 25 is equal to this angle because they share that 50-degree angle. They're both inscribed. So this is 25. I know that. All right. And now if I could figure out this angle, we're in business, right? That angle. Now that angle is inscribed to this big arc DE. In order to get the big arc DE, I'm going to have to use this 42-degree angle here. So our outside is different. So 42 is equal to the big arc, which is DE, minus the small arc, which is 50, and then cut in half. So we're going to head and cross multiply first. So 84 is equal to DE minus 50, and then we add the 50 to get, okay, 134. And that's the measure of this arc over here. And so now we know that this is 134, DE. I can figure out this angle B because it's half of that. And so that is going to equal 67. That's half of 134. 134 divided by 2, 67. And so now I can figure out the angles on the triangle here. Now I also, as a difference, could have done this angle right there, right? Done the average to get this and then done 180 minus. So it's totally up to you how you want to handle that. I'll leave it up to you guys. 25 plus 67 is 12 carry the 1, 92. And 180 minus 92 is 88. And so that's the measure of those two angles. Okay, so the measure of angle DFE. And so let's see, one more time. DFE, well, that's inscribed to the 134. So that's 67. That's this angle. Okay, make sure we answer the question. And the measure of angle DGB, we said, was 88 degrees. And there's our two angles. Head to the next page. Okay, number 3. So same thing. Once again, I'm noticing that I have these parallel lines. So I'm looking for my Z. So I can see right here if this is, and it's hard for me to see, I have to go back to the map. This is 56. That's where the 56 came from. Okay, so 56 degrees here. That means that this angle is also 56 degrees. Okay, so we're going to keep that in mind. I'm going to go look for my two angles I'm looking for. The first one is angle ECD. So ECD is the one that's formed outside the circle. Okay, so I'm going to need those arcs to get that one. All right, or the triangle there. Let's call this X so that we have a reference here because we have 3 angles going on. Okay, the second angle is DBE. All right, so DBE. So this is inscribed. So we're going to need to know arc DE to get this one. Let's call this Y. Okay. And the last angle is angle Z. Well, we'll call it Z. But that's DEB. And that is angle DEB. So really we're going for the angles in those triangles there. Okay. So 2 things. Number 1, I know that this angle BDE, which we already figured out was 56, makes this arc 112. We were into the light here. 112. Okay, we're just doubling that. So we'll keep that in mind. Okay. And this other angle we have going on here, you can see this angle is formed by a tangent line, right, and a chord. So that means that this arc, DE, is 2 times that 56-degree angle. So this is also 112. All right, so that's important here. So angle Y is going to be half of that because it's inscribed. So now we know angle Y is also 56 degrees. All right, so we're on the 1, we're halfway there, well, third. Okay, and also important because this arc DE we traced earlier is 112. Then I know the other side of the circle, all the way around over here, has to make 360 with that 112. So 360 minus 112, I believe we said earlier, is 248 degrees. And now I can do the outside is different, and I can figure out what X is. Okay, Also, once we know that this is 248, right, this other arc, BD, is 248 minus 112, which is 6, 3, 136, and angle Z here is inscribed to there, right? So we can do 136 divided by 2, 136 divided by 2, which is 668. So that's the measure of this angle, all right? And then we can do that outside as different thing to get the measure of x, which we'll do it red. So that's x is equal to the bigger minus the smaller. So 248 is the bigger minus the smaller, which is 112, and then divided by 2. So that's 6, 3, 1, 136 divided by 2, which we already established is also 68 degrees. And so that's the measure of that arc. So we have 68, 68, and 56 for the measure of our angles. Perfect. Okay, let's head over to number 4. All right, so I have two angles. Once again, I have an inscribed angle where D is. So I have inscribed. So that's going to help me get that arc FE. Okay. So we know this is 56 because it's double. We also have that exterior angle there, the angle on the outside, I should say. And so remember, this is going to form outside is different, so we can figure out dB. All right, we'll get there. Next thing we want to do is focus on our angles. So what two angles are we looking for? So I'm looking for angle FGE. So FGE is right here, and we can actually do that now because we have the 56-degree arc. So that's 1/2 of 56, which is 28. It's also equal to this angle because they're both inscribed to the same arc. So now that is 28 degrees. Perfect. Okay. The other one is going to be angle, we'll go green for this one, FHE. So FHE, and that is inside the circle. And so remember, for inside, we actually need the two arcs formed by the vertical angles here, okay? So we're going to need to know this other arc, DG. And to do that, we need our exterior angle again. So remember, outside, I shouldn't say outside, not exterior, outside. Outside is different, that means subtract. So the angle is equal to the big arc, which is DG, okay, minus the small arc, which is 56. Now, if you want to put an X here, just call it X, go for it, because we're not using an X anywhere else, okay? And then we're going to add the 56 to both sides, and we'll have 96 for our arc. That's equal to DG. All right. And so now that we have 96, I can do the average. Okay. So angle FHE is equal to 96 plus 56, and then divided by 2. So that's 12, carry the 1, that's 152 divided by 2, which is 76 degrees. And so that's the measure of angle FHE. All right, and there's our two angles. Okay, head down to number 5. Same type of question here. So we have a bunch of angles going on that can help us out. All right, now two things I noticed. Number 1, okay, I notice I have a triangle. I also have two inscribed angles for X and Y. So X is right here. So if I can figure out the measure of this arc, I can get X. And number 2, I have another inscribed angle at Y. And so if I can figure out this arc, I can get Y. All right. Thirdly, I know this is 94, so that can kind of help us get, if we get one, we can get the other. All right. So that's our goal right now. So let's see if we can use these arcs here. Okay, so I'm really looking at this question, and I can figure out one way to do this, and that's using a system. So I'm going to do a magic trick, and I'm going to make the answer appear. So on the count of 3, the answer is going to be there. You ready? 1, 2, 3. Okay, so what you guys got going on here is I'm going to call this arc over here, right? DG, B, and FEA. So the two things we have are we have the angles inside and the angles outside. So remember, when we do inside, it's the average. So the first equation is 94 equals A plus B. And for outside, it's the difference. It's outside is different, so it's minus. So I took the inside formula, I solved for A. I got 188 minus B. And then all I did was take the equation on the other side, which is 34 equals 2 times B minus A. I cross multiplied, and then I just went and plugged that in for A. And then I solved, and I got 128. I would not ask you to do this on your own. So just by doing the magic trick here. So now when I want to get A, I just do 188, okay, minus 128 is equal to A, and so A is equal to 60. So B is equal to 128, okay, A is equal to 60, and so I can get now X and Y because it's just half. So X is half of 128, which is going to be 64, and Y is half of 60, which is 30. All right. I'm not going to do number 6. Sorry, Devet, it is a SOHCAHTOA question, but we're not going to do it. But on the next page, we are going to take a look at number 7. A little interesting one here. So for number 7, you're actually going to need to draw in these triangles. I'm going to need to draw the lines FB, BG, and GF. Now, if you remember, the key thing why we're drawing them is because I'm now creating these triangles out here, right? And these triangles are actually using the hat rule here. So each of these lines we're drawing, okay, are forming these congruent tangents, congruent parts of the tangent line. All right, so I know that this side is equal to this side, and therefore this angle is equal to this angle. Same thing here. These are equal. These angles are equal. Okay? And then same thing here. All right? Now, once I can figure out, all I need to do is get those 3 arcs. So once I can figure out what these base angles are, remember that each of these base angles, okay, is being formed by a tangent line and a secant, tangent chord. So this arc is just 2 times the measure of that base angle. That's it. Okay, so if we do 180 minus 70 divided by 2, right, that's going to be 110 divided by 2, that's equal to 55. So once this is 55 degrees, this arc becomes 110 degrees. Okay, likewise, if I do 180 minus 40 divided by 2, that gives me 70. So that's 140 divided by 2 is 70. And once this is 70, this arc becomes 140. All right? And because in our triangle here, if I have 70 and 40, that's 110. So this angle is going to be 70 as well. Okay? This is 70 plus 40, which is 110. And then 180 minus 110 is going to give me 70 degrees. And once we know this is 70, we now know that this angle is going to be 55 because we already did the math, and this arc is also 110. Also, once we have 110 and 140, get 250, we can just do 360 minus. So that's how we're going to get those 3 arcs. That's it for today, guys. We're not going to go through anything too crazy here. We're not going to worry about this proof, why BD equals BE. It's pretty simple. We already know that we can draw these 2 lines in actually and just get that these triangles are congruent, okay? And then we can do some CPC/TC to get there, but we're not going to worry about that. So guys, I hope you have a great day today. Remember, the Nearpod is up there. It's actually going to be, I think, a Schoology quiz this time, or assignment on Schoology. Just check it out and have a great day, guys.